Okay, so today let us see some important applications in Newton laws, like connecting bodies and contact bodies. So I just want to show you the difference between contact bodies based applications as well as connecting bodies based applications. Almost 90% both are having the same logics and application. Only the difference is here in contact bodies, let us consider this is body having mass m1 and this is body having mass m2 and this is another body having mass m3 you take, right? So three blocks m1, m2, m3 are kept in contact. It's okay. Now external force F is applied on m1. Listen, here external force F is applied on m1. It's okay, right? Now because of this external force, let's consider the entire system is moving with acceleration a, and consider this as smooth surface, no friction is present. So due to external force capital F on m1, the three bodies are moving with acceleration a you take, because there is no opposition, right? So that is contact bodies. Even though F is not applied on m2 and m3, F is applied only on m1, but all the three are moving with acceleration a. So m2 is moving due to contact force between m1 and m2, and m3 is moving because of contact force between m2 and m3. So between m1 and m2 and m2 and m3 you will expect the contact force. So usually in these sums you will be asked the value of the contact force either between m1 m2 or between m2 and m3, right? So this is solved purely with the help of free body diagram. So let us consider here this is m1, and let's consider F1 is the contact force between these two. So the F1 contact force on m1 will act like this, but the same contact force, right here, the same contact force on m2, this is m2. If F1 is contact force between m1 and m2, then the direction of contact force will be like this between m1 and m2. Okay, let's consider between these two contact force is F1 and between these two contact force is F2. So if you separate it and visualize the effect of contact force on m1 and m2, then here on m1 contact force will act towards the left side, but on m2 it will act towards right side. So this can be understood with the help of this one, Newton's third action reaction. See, when F is applied on m1, then m1 will apply force on m2, this one. Meanwhile m2 will apply reaction force on m1, which are equal and opposite, so that net force is 0. That's why they are in contact. Otherwise, if some unbalanced force is there, then m2 will separate from m1. Is it or not? Here m2 is not separating from m1. M3 is also not separating from m2. Even though all the three are moving together, m2 is not separating from m3 and m3 is not separating from m2. Meanwhile, this is not separating from m1. Is it or not? So because the net contact force is 0 between these two bodies, but contact force is present. Net is 0, kind of action reaction. For every action there is equal and opposite reaction. So net force will be 0, right? Okay. So this F1 and this is also F1. So this is the contact force between M1 and M2, and this is external force on M1. But if you take FBD between here M2, M3, so if you draw M2 and M3, then this is M2. Better do one thing. I want to draw here itself. This is M2 now, between M2 and M3. This is M2 and This is M3. Try to write down the formula between this M2 and M3. Right. See here. On M2 again, let us assume F2 is contact force between M2 and M3. Then this F2 exerted by M2 on M3 will be towards right. But the same force M2 will exert on oh wait. Right, here you need to take M2 and M3, no? So this is the force F2 will act on M2 towards left, and this is a force F2 will act on M3 towards right. And meanwhile M2 also experiencing F1. That's it. This is a visualized FBD for understanding contact force related application. Here capital F is applied between M1, M2, M3. Sorry, only on M1. But M2 and M3 also moving due to contact force between M1, M2 and M2, M3. And this is the contact force. Net contact force will be 0. So if you take separately, here cut it and check it. Between M1 and M2, F1 is acting like this. And between M2 and M3, F2 is acting like this. Means M1 is experiencing two forces, capital F and F1. And M2 is experiencing again two forces, F1 and F2. But M3 is experiencing only one force. What is that? F3. And no doubt all the three are moving with acceleration A. So M1 is moving with acceleration A. And M2 is also moving with acceleration A. M3 is also moving with acceleration A. Now try to write down the general equation here. Right. Try to take the general equation of motion for M1, M2, M3 separately. Clear this is? Motion of contact bodies, right? Here action reaction F2 net force between M2 M3 is 0. Here also F1 net force will be 0. Okay. Now if you take motion of M1. So if you consider the motion of M1, M1 is experiencing net force this one. F minus F1 is equal to M1A, you can write. This is first equation. And if you take the motion of M2, right, M2 is experiencing F1, F2, then the net force will be F1 minus F2 because it is accelerating towards right. So F1 must be greater than F2, otherwise M2 can't move. So F1 minus F2 is equal to M2A, you can write. This is the second equation. Next. If you take free body diagram of M3, so M2 experiencing, this is F1, this is F2, and this is experiencing, this is capital F, this is F1 as per FBD, as per the analysis, and M3 is experiencing only F2. See, there is no other force. Then here you can write F2 is equal to M3A. So take this as third equation. Clear? Net force equation I have written. Since all M1, M2, M3, all the three are in motion, I have taken the net force equation. Capital F minus F1 is M1A, this is M2A, and this is M3A. So now see here. Before getting into calculating F1 and F2, usually here in this case you will be asked to find out F1 and F2. So before getting into calculating F1 and F2, let us write the formula for acceleration here. Try to take the formula for acceleration. Since the surface is smooth here, M1, M2, M3 are kept on smooth surface, so therefore no opposition, no frictional force. And net force between M1, M2 is always 0, and between M2, M3 is always 0. Therefore acceleration is always written as net force by total mass. That is F by M1 plus M2 plus M3. Standard formula. On this is, check it. A is equal to F by M1 plus M2 plus M3. This is standard formula for acceleration for contact bodies. Anywhere, not only in the Newton laws. If you want to find out formula for acceleration, just use net force by total mass. This is, we are taking from Newton law, F equal to ma, that's it. M is the total mass of the system. When external force is acting on the system, so obviously the body will get into the acceleration. In that case, acceleration is always calculated as net force by total mass. Now we got a value. Then try to write down formula for F2 here. From third equation I can write F2 is equal to here. Here I can take F2 is equal to, that is M3 into A. M3 into acceleration is this one, that is F by. M3 F by, you can write this is, let's write from here F3 is equal to, otherwise just I want to move this. Wait. Right, F3 is equal to, from the third equation I can write M3 into A. By substituting A value from here, you can write F3 is equal to M3F. In place of A, just replace this, M1 plus M2 plus M3. So this is the value of not F3, F2, right? Right. So this is the value of F2. F2 is M3A. Only replace A with this value so that you will get F2. Therefore, the contact force between M2 and M3 can be written as M3F by M1 plus M2 plus M3. Similarly, if you want to write down F1 here from this equation, if you want to take F1, so F1 is F1 minus F2 is equal to M2A. So here F1 is equal to M2A plus F2. But here F2 is M3A. So replace that. Then M2A plus F2 is M3A. So that here you can write F1 is equal to finally M2 plus M3 into acceleration. Or else the final equation for F1 will be M2 plus M3 into acceleration is F by M1 plus M2 plus M3. So this is a way of calculating contact force between M1, M2 and M2, M3. See the formula. F2 is M3F by M1 plus M2 plus M3. This one. And F1 is M2 plus M3 F by M1 plus M2 plus M3. If you get a question in the Neet, then it will be directly asked either F2 or F1. This kind of situation will be given. Sometimes only two bodies will be given, right? Here I have taken 3. And even if you take 4 bodies also doesn't matter. After looking this F1 and F2, you can even write down F3 easily. For 4 bodies, 5 bodies. For any number of bodies, you can generalize it. So copy it. Copy it. If you copy, then I'll take connecting bodies. Doubt anywhere? Almost in Newton laws, every problem can be solved with proper visualization. Any application you take in the Newton laws, directly or indirectly linked with force only, like F equal to ma, as long as mass is constant. When mass is variable, we will take some variation in that, but ultimately net force is ma. So in the given system or in the given situation, you are supposed to take only net force equation. So right, next you take same connecting bodies. This is contact bodies, no? Contact bodies means kept against each other on a smooth surface. So next you take connecting bodies here. I'm taking connecting bodies. See, exactly the same objects which we have assumed like in the previous application. Same. Take M1, M2, M3. So this is M1, this is M2, and this is M3. And let's consider these were connected with the help of two strings. This is one string and this is another string, and nature of the surface is smooth. Now let's consider here the pulling force F is applied. So in the previous case, the same F is pushing and this is pulling force. In the previous discussion, so this nature of this force on M1 is pushing. Same magnitude, no change at all. This is pushing force, right? But in the present case, we have taken pulling force, capital F, and M1, M2 connected with one string, and M2 and M3 connected with another string. Unless mentioned, you must take the nature of the string as light and inextensible. Light and inextensible. No mass of the string is considered. Almost throughout Newton laws, this will be the standard assumption. Okay. So let us consider. See, here M1 is pulled, so that M2, M3 moving along with M1. In the previous case, M1 is pushed, so that M2, M3 moving along with M1 or accelerating along with M1 because of contact force. Here also, due to this pulling force, M1, M2, M3 moving with acceleration A you take on the smooth surface. But this happens due to the tension force present in the string. Tension force is responsible for the motion of M2 and M3 because this is a string. Let us consider tension is T1. Right. Right. So tension here is equal to T1 you take between M1, M2, M2, M3 is equal to tension T2, you assume it. Now the direction of the tension, since tension is always the pulling force, here the nature of tension is pulling force. It pulls the object, and the nature of M3 is pulled by T2, therefore the direction of T2 on M3 will be like this, and similarly M2 will be pulled by this T1. Meanwhile here this string T2 will oppose the motion of M2, because since it is a pulling force, at any point its direction would be away from the considered, away from here. In a string, with respect to a point, direction of tension must be taken away from it, because it is a pulling force, no? You have to take it away from it. So here with respect to M2, T2 will act towards left, but the same tension here will act towards right, because here this T2 trying to oppose the motion of M2 and the same T2 is trying to pull M3, and here T1 is trying to oppose the motion of M1, but same T1 is helping M2 to move forward. The reason is, when you draw the free body diagram, direction of tension must be taken away from a considered point. Clear? Right. Already here in the given figure itself we have taken T1, T2 directions. Now try to draw the free body diagram for M1, M2, M3 separately. Right. I am taking first M1 here. M1 is experiencing two forces, that is capital F, and tension T1 is acting towards left. And before getting into FBD, let us write down the formula for acceleration. Here also acceleration can be written as net force by total mass. Since the surface is smooth, right, and between M2 and M1 tension is acting in opposite direction. Same tension is acting here and here. So net tension between the two is 0. Clear? On M1 T1 is present, but between M2 and M1 the net tension is 0. Otherwise, if there is net tension, either the string will become loose or it will break. Clear? So it is not breaking or not loosening, then obviously tension at any point should be same, right? Here also the same thing, T2 T2 acting equal and opposite direction on M2 M3, so net tension is 0. That's why if you want to write down net force on the system M1 M2 M3 bodies, then it will be F by M1 plus M2 plus M3. Clear? Net force is F by M1 plus M2 plus M3. Now if you take only this M1 FBD, then see, here M1 FBD means it's accelerating like this, so that simply you can write capital F minus T1 is equal to M1A, right? This is first equation. Now this is acceleration. So try to take FBD for M2 here. So T1 will act away from it. See the figure. T2 will act again away from it. But T1 away gives right direction, T2 away gives left direction. T1 away is right direction, T2 away is the left direction. So that it is moving with acceleration, A you take. So here net force will be T1 minus T2, that is equal to, you can write M2A. Take this as second equation. Now if you take FBD for M3, here M3 is experiencing only one force, that is T2. In the figure check it, this is M1, no? And if you take M2, M2 is having two forces, but if you take M3, M3 is having only T2 force, this side no other force. So only T2 is responsible for the acceleration of M3. Then you can write T2 is equal to M3A. This is our third equation. Now we have written FBD for M1, M2 and M3. 3 FBDs we have written. Now since we know the acceleration as all the time net force by total mass, better replace this acceleration over here so that you will get T2 directly. So that here T2 is equal to, we can write down its simplified value as M3F by M1 plus M2 plus M3. So this is T2, right? Now since T2 is M3F by M1 plus M2 plus M3, and if you want to take T1, look at this and try to make T1 as the subject, take this to that side, then M2A plus T2. But here T2 is equal to M3A. Replace T2 with that, therefore you will get M2A plus M3A. So T1 would be finally M2 plus M3 into A. Since acceleration already we have written, final simplified value for T1 would be, right, here M2 plus M3 into acceleration F by M1 plus M2 plus M3. That's it. So this would be the T1, M2 plus M3 into F by M1 plus M2 plus M3. That's it. So that is T1 and this is T2. Now compared with the previous connecting bodies and contact bodies, just check it. Here T1 is M2 plus M3 F by M1 plus M2 plus M3 and T2 is M3 F by M1 plus M2 plus M3, and previous case you check it. F2 is M3 F by this one, F1 is this one, exactly same formula. Means whether you take contact bodies or connected bodies, here T1, T2 and F1, F2 are same. But only the difference is, here in case of connecting bodies, the nature of tension is pulling force. Because of pulling, all the three are accelerating. But in the previous case, because of pushing, all the three are accelerating. Only the nature of force is different, but the way how accelerating due to force capital F is same. You shouldn't confuse. You have to take the free body diagram correctly, then you need to go ahead. Clear? Right. So next, let us take one more application, that is the try to take motion on inclined plane. So as long as you consider motion of a block or body on inclined plane, first you need to check whether the nature of the inclined plane is smooth or rough. Here I am taking smooth inclined plane, and I just wanted to show the comparison for smooth inclined plane as well as for rough inclined plane. So same here, I just wanted to take rough inclined plane. If I give a comparison, then all the time you will have a specific idea, right? Next. As long as smooth inclined plane, no friction is considered, but here friction will be considered. Their friction will not be considered. So let's consider this is the smooth inclined plane, inclined at an angle theta. First focus on the free body diagram, and here this is a block, and it is a rough inclined plane where friction is present, right? This is a block, inclination theta. Same, but one is smooth, another is rough. So as long as smooth inclined plane is considered, the forces acting on the body would be, from the center gravity will act vertically downward mg, and normal reaction will act normal to the surface. These two forces will act. But if you take rough inclined plane, on rough inclined plane no doubt gravity will be applied vertically downward. Normal reaction will be normal to the surface. All the time normal reaction will act normal to the surface. Since inclined surface is like this, I have to take in this direction. Now clearly here, weight and normal reaction are in different directions. But if you take the horizontal surface, on a horizontal surface, if the same block is kept, then weight acts vertically downward, normal reaction will act normal to the surface, so that you can write comfortably N is equal to mg. Gravity balances normal reaction on a horizontal surface, right? But whereas on inclined plane, gravity is not balancing the normal reaction. So that's why we will resolve here, right? Here we will resolve gravity along normal reaction and perpendicular to normal reaction. So as a part of that resolution here, if this is theta by geometry, this would be theta, and this will become mg cos theta, and normal is nothing but along the plane. This will become mg sin theta. That's it. But on rough inclined plane, same resolution is there. So this will be mg cos theta, and this will be mg sin theta. But here no friction, here friction is present. Since normal reaction is balanced, there is no vertical motion, right? Vertical motion in the sense there is no motion along this direction, normal direction. But the body is having the tendency of sliding down. So the nature of friction is to oppose the relative motion between contact surfaces. Okay. So since mg sin theta is acting downward, the direction of friction here is always expected upward. This is the friction. Suppose if the block is at rest, then nature of friction will be static. If the block is moving, then this will be kinetic. Static friction is the one which acts on stationary object. Means external force is acting on the body but it is not moving. In such case, friction experienced by the body is static. And external force is applied and the body is in the acceleration, that is moving. Then in that case, the nature of friction is kinetic. So since we are not sure whether it is static or kinetic, just I have taken only F. But compulsory here F will act upward only. I am just focusing on the direction. So since there is no opposing force, this will 100% will come down with acceleration. Yes, so that you will write here mg sin theta is equal to m into a, where m is the mass of the block. So since mg sin theta is equal to ma, you can cancel m and m, you can write a is equal to g sin theta. So when a body is kept on an smooth inclined plane, then motion is inevitable because mg sin theta will not get balanced over there. Along the plane, there is no other force to balance mg sin theta. Understood? Here, there is no other force to balance mg sin theta. Therefore, A can be written as g sin theta. After that, for further analysis of the motion, we will make use of the kinematic equations. That is, V is equal to U plus AT, or S is equal to ut plus half at square. These standard kinematic equations are used, or v square minus u square is equal to 2as. In very rare case, Sn can also be used, u plus a by 2 into 2n minus 1. These all equations are familiar to you know. With the help of this kinematic equation, the next level of discussion will be done on this inclined plane. And here, coming to rough inclined plane, right? In the rough inclined plane, mg sin theta is acting downward, it is acting upward. Let us consider it is coming down with acceleration a. This I am assuming. So that mg sin theta dominates Fk, that is friction, therefore it is coming down. Here in this case, you can write the net force as mg sin theta minus Fk is equal to m into a. Did you understand? Check it. Here no friction is present, therefore you will write mg sin theta is equal to ma, due to which a is equal to, you will write g sin theta. And since you got acceleration, you can use comfortable F is equal to ma. What is the force that is bringing it back? That is equal to F is equal to ma, that is mg sin theta. This is a force responsible for the motion of this block down the plane. And for finding the displacement, velocity and other cases, right, you will take this kinematic equations. Now here mg sin theta minus Fk is equal to ma, but here we know that Fk is equal to, all the time you will write mu k into normal reaction. Here in this formula, normal reaction can be taken as n is equal to mg cos theta. Here normal reaction is balanced by mg cos theta. Here mg got resolved along and perpendicular. Then mg sin theta minus, in place of Fk we can write mu k mg cos theta. Formula for kinetic friction is equal to m into a. Check it, m get cancel on both sides in this equation. Now if you want to make a as the subject, then a is equal to, g can be taken common, sin theta minus mu k cos theta. So when you are solving the problems related to, right, so when we are taking the problems related to rough inclined plane, this would be the acceleration down the plane, that too. This is when the body is moving down the plane. And even you can do for up the plane also, plus will come, that's it. And for taking the discussion of motion of the object to the next level, that is calculating displacement, velocity and all, again you will make use of this kinematic equations. But wherever acceleration is there, here this acceleration is replaced with this for rough inclined plane, with this for smooth inclined plane. That is only the difference. So even if you get problems related to inclined plane also, don't confuse. You just check it whether it is rough inclined plane or smooth inclined plane, then go ahead. Copy it. So I think as far as Neet is considered, you can't expect higher level uh, constant equation based applications. The direct sums will be given. Like before I have explained connecting bodies, contact bodies. No, this is inclined plane, rough and smooth inclined plane. Next, let us see simple atwood machine. Sometimes there is a chance of getting question on atwood machine also. And earlier also I got. Copy it. So take atwood machine. So in atwood machine, let us consider this is a light pulley, and over light pulley let us also consider a string is passing over it. Let us take this is block M1, this is block M2. So two blocks M1 and M2 were connected, right? And let's consider here M2 is greater than M1, mass of M2 is greater than M1. This is the situation I am taking. So simple atwood machine is nothing but it consists of a smooth pulley, a single string and two blocks. Here it is a smooth pulley, single string and two blocks. So this is the simple atwood machine. Now in this simple atwood machine, you will be asked to find out the tension in the string as well as acceleration of M1 and M2, and also the net force acting on the pulley. Those two things will be asked. 1, 2, 3 cases. In the simple atwood machine will be expected 3 different observations. And unless mentioned, usually in the Newton laws based applications, pulley is always treated as inextensible. This will be. And string is always considered as light unless it is mentioned. The default assumption itself, pulley will be right here, string will be light and inextensible. Right, means no mass and no extension. Practically when you hang some weight it will get extend, but we will ignore extension, because if you consider extension you need to take Young's modulus, and we have to shift our discussion to the elasticity, mechanical properties of solids. But here our discussion is to understand the motion of the blocks. The main motto is to understand the motion of the blocks. No doubt in this one block will accelerate upward, other block will accelerate downward. In constant equations we will see that A1 and A2 will be having, that is this and this will be having same acceleration when it is inextensible. It can't get extend. So that we can avoid the Young's modulus and related theory of wire. theory related to the string can be neglected. Our focus is only to understand the nature of pulley and this motion of the blocks, right? So that's why this is assumption, and pulley will be smooth and light. Every time you shouldn't be in the thinking of whether pulley is massive or massless. If it is mentioned, then only I have to consider, otherwise the default assumption itself is pulley all the time, smooth and light, string all the time, light and inextensible, massless. Now try to take the free body diagram. Since the string is light and inextensible, tension at any point in the string remain constant, and since tension is a pulling force, on M2 it acts in upward direction, and even on M1 also it acts in upward direction. Right. Now if you take separately FBD of M1 and FBD of M2, then M1 is experiencing tension upward direction, right, and here even M2 also experiences tension in upward direction, like this, and gravity will act downward. All the time gravity direction will be standard and fixed, but according to the question here, you can say here T is dominating weight, gravity, but here gravity is dominating tension, due to which this block can be expected coming down, this block is expected accelerating upward. That's it. These are the FBDs. Check it out. The Atwood machine, simple Atwood machine, 2 blocks, 1 string and 1 pulley will be there. And if you want to calculate the tension as well as acceleration of M1 and M2, the motto itself is to understand the motion of the blocks. You need to take the free body diagram for M1 and M2 like this. Now here if you take the net force equation, you will write like this: T minus M1G is equal to M1A. So take this as first equation, right? And again here M2G minus T is equal to, you will write M2A. This is the second equation. Check it out. First equation and second equation. T minus M1G is equal to M1A and M2G minus T is equal to M2A. So this and this are crucial. Net force, when you are writing down MA, net force is equal to MA, greater force minus smaller force you need to take, right? Now solving 1 and 2, you will get a standard formula for acceleration as well as tension. But meanwhile here, for acceleration you can directly use this formula, since only 2 blocks are there, right? You can apply this formula directly, net force by total mass. Here the force acting is only gravitation, M2G downward, this one. So simply you can write here M2G minus M1G by M1 plus M2. That is, acceleration is the net gravitational force. This is accelerating because of net gravitational force. Or net pulling force is M2 minus M1 into G by M1 plus M2. That's it. So got acceleration for Atwood machine, simple Atwood machine. And for getting tension, you take either this or this. So I'm taking this first formula. Okay, right. From first formula, I can write T minus M1G is equal to M1A and make T as the subject here. So T, if you make the subject, M1 into G plus A you will get. Right now T is equal to M1 into G plus, right? A is equal to M2 minus M1. m2 minus m1 into g by m1 plus m2. So even you can take g also common. So this is equal to m1g. m1g into inside you will get 1 plus m2 minus m1 by m1 plus m2. Try to do this simplification inside the bracket. So 1 plus I am doing it separately, m2 minus m1 by m1 plus m2. Now here LCM would be m1 plus m2 and m1 plus m2 plus m2 minus m1. So this and this get cancelled. So that finally you will get 2m2 by m1 plus m2. So this is inside the bracket. So finally tension can be written as, you can take, I need some space. Right. So here finally tension is equal to this is m1g into this one is this one. No? So you will be getting 2m1 m2 g by m1 plus m2. This will be the tension formula. 2m1 m2 g by m1 plus m2. Tension based formula it is, right? So this is the information related to simple Atwood machine. So we'll be having even variations and 2 more strings, 3 more blocks, but I think in Neet we can't expect many questions on constant equations, right? Okay. Copy it.